All right, so welcome to today's class. We'll be looking at the average atomic mass and the percentage abundances. Okay, so as always, okay, if I explain anything and you do not understand whatever I've explained, okay, feel free to just unmute your mic and then you ask the question, okay, so that I explain. Okay, so we started a long time ago, like 2 weeks ago. That's when we started our lessons. So we've been having them continuous for 2 weeks. This is the third week. Okay. If you missed any of the classes, you can simply go on the YouTube channel. You're going to find all the classes that we've done. Okay, we've done physics, we've done biology, we've done math. Okay, and here we are continuing with chemistry. So for all the classes that you missed, you can find them on our YouTube channel, which is Discrete Learning Institute. Okay, you're going to find them. So if I explain anything you do not understand, please don't feel shy. I'm not there where you are. Okay. I'm very far away from you. So make sure you ask and you understand, okay? Because as you can see, when you go to the lectures, there are a lot of you, okay? And sometimes you sit at the back, you can't even see whatever the lecture will be talking about. So this is a very good platform where you can easily interact with me, okay, or any of the other tutors that I work with, okay? So uh, yeah, so feel free. Okay, you can contact me, you can inbox me if you want to know about anything like how we do our lessons. Okay, so we'll be looking at the average atomic masses, okay, and the percentage abundances. Okay, so what we'll learn in this video today or in this class, I've outlined it here. Okay, so I'll start from the very basic concepts that you guys know. Okay, I'll start from the atoms. Okay, we'll define what the atoms are. Okay, and then we'll go to the subatomic particles. And then from there, we go now to what we want to talk about today, which is isotopes and how to calculate the average atomic mass as well as calculate the relative what abundances or the percentage abundances. Okay, so let's start. Okay, so we start from the atoms and the subatomic particles. Okay, so we know that an atom is the smallest indivisible particle of an element, right? Okay, so the smallest indivisible particle of an element. That's what an atom is. Okay, so each particular atom will make up a certain type of element. Okay, each particular atom will make up a certain type of element. Okay, that's where also the definition of elements comes in. So we know that an element is simply a pure substance that is made up of only one type of atom. So meaning that that element cannot be broken down into simpler substances by any chemical means that you can do. Okay, by any chemical means that you can do, they will not be broken down into what? Simpler substances. So examples of these elements, okay, or in other words, you can say atoms, you can say oxygen, okay, you can say maybe hydrogen, okay, and you can say maybe carbon. Okay, so these three here are enough. Okay, so now these atoms, okay, these atoms are made up of what we call subatomic particles. Okay, so the subatomic particles, we have three of them. Okay, I know you guys know them. So I'll draw like a tree here. Okay, so we have one, the protons. Okay, and then two, we have the electrons. And then three, we have the what? The neutrons. Okay, so we know that if you are to draw an atom, that picture that you are used to at grade 12, you said you had like a nucleus somewhere there. Okay, remember this? And then around it, you had those shells. So we said in this nucleus here, okay, we are going to have the protons and the neutrons, right, in the nucleus. And then in these shells now, that's where we are putting our electrons like that with an X, or is it a dot like this? Okay, to represent the electrons. So the neutrons and the protons, they are in the what? In the nucleus. And then the electrons are in the shells that are around that nucleus. Okay, so each of these particles has a specific importance or a specific job or a specific responsibility that it does in this what? In this atom. Okay, so we'll start from the protons. Okay, so the protons, we know that these protons are the positively charged particles of this what? Atom. Okay, they are the positively charged particles of the atom, and they are found in the nucleus, and they have a relative mass of 1. Okay, so the protons are just the positively charged, okay, particles of the atom. So what is their importance? Okay, what is their importance? These protons. So the protons, okay, they are going to define the element. Okay, so what do I mean by that? They give the element its identity. Okay, so there are not two elements. Okay, there are not two elements that have the same proton number. Okay, so meaning that if you have any elements, okay, if you have any two elements that have the same proton number, then they have to be the same element. Okay, they have to be the same element. So the proton is responsible for identity. Okay, it identifies the proton. Okay, it identifies the atom. Okay, so if you hear that, for example, any element has one proton. Okay, so we only have one element that has one proton, and that element is the hydrogen. Okay, is the hydrogen. Or if I say, give me an element that has 6 protons. Okay, the element that has 6 protons on the periodic table is only what? Carbon. Okay, if it has maybe 8 protons, okay, the only element with 8 protons on the periodic table is what? Oxygen. Okay, so this is what the protons do. They give their identity to that element or to that atom. They give it its identity. Okay, so whenever you see protons, whenever you see atoms, okay, with 8 protons, just know that, okay, this atom must be of oxygen because it has 8. Okay, and then whenever you see elements with 1 proton, just know that, okay, this atom here must be of what? Of hydrogen. Okay, so the proton give their identity, okay, to the what? To the element. Okay, so they also determine what we call as the atomic number. We're going to define it, okay? So the atomic number is simply the number of protons that are in that element. That's the atomic number, okay? The number of protons that are in that element. Okay, and then they also give this atom a positive charge because we said they are positively charged. So they will give the nucleus a positively charged. So this also means that without protons, okay, then the atom will not exist. Okay, so without protons, without protons, there is no element that exists. So the protons give the identity. Okay, and then let's talk about the electrons. Okay, so the electrons, we know that these are the negatively charged ions. Okay, these are the negatively charged uh, particles in the atom. Okay, so electrons, I'll write it here. So these electrons here, they are negatively charged. Okay, negatively charged particles. Okay, and they are found around the shell like that. So there's a reason why these electrons are found around the shell there. Okay, so they are found around the shell here so that they can easily interact with other what? Elements. Okay, so they are responsible for the what? For the chemical interactions of the atom. Okay, so that's the main job of the what? Of the electrons. They are responsible for the chemical. Okay, they are responsible for the chemical behavior of the what? Of the atom. Okay, they're responsible for the chemical behavior of the atom. Why? Because they are found in the shells there. So it's very easy for those particles to react with the particles in another what? Atom. Okay, so they carry out these interactions in 2 ways. One, they can share the electrons. Okay, so if they share the electrons, that's what we used to call as the covalent bonding, right? Okay, and then if they transfer electrons, meaning they gain electrons or they lose electrons, we used to call that as ionic bonding. Okay, so that's the main purpose of the electrons. They are simply there, okay, for the chemical interactions. Okay. They also determine what we call as the valence. Okay, so the valence is just how many electrons they are going to gain or how many electrons they are going to lose in order to achieve a stable state. Okay, they also determine that. And because of these electrons also, okay, they decide if the element is going to be a metal or if the element is going to be a non-metal or if the element has now become what? An ion. Okay, so if they are able to give out electrons, if they're able to lose, if those electrons are able to be lost from that atom, okay, then you know that that atom is actually what? A metal, because it can donate electrons, okay? And then if they're able to gain, okay, if they're able to gain, then they're going to be what? Non-metals, okay? And by the fact that they are gaining and losing electrons, okay, it creates an imbalance, okay, of the positive charges and the negative charges in the atom, okay. So you end up having what we call as the ions, okay. So without electrons, we would have no chemical reactions, okay. We would have no electricity, we would have no compounds, okay, because nothing will be reacting. So the electrons are very important for the chemical properties of the atom. Okay, the other ones are the neutrons. Okay, so the neutrons, these particles are the ones that are going to drive whatever we are going to be talking about today. Okay, so these neutrons here, these ones are found in the nucleus together with the what? With the protons. Okay, so the most important thing that these neutrons do is that they add mass to the atom. Okay, they add mass to the what? To the atom. They make the nucleus stable by adding more mass to that what? To that atom. Okay, and these neutrons here are responsible for what we call as isotopes. Okay, so this was a very common definition in grade 12. What are isotopes? You guys used to sing this. Okay, so yeah, so the ones that are responsible for making isotopes, it's actually the what? The neutrons. Okay, so that's their main responsibilities there. Okay, so now they are the protons. Okay, if I can go back, we said they are positively charged. So the protons, they never move from the nucleus. They are always going to be in the nucleus. Okay, the electrons, we say they are negatively charged. These electrons can move away from the shells here. Okay, they can move away from the shells. They can be lost or the atom can gain more electrons. So the electrons can actually move. Okay, they are not stationary. And then these neutrons here, okay, these neutrons here, even them, they are stationary. They are in the nucleus, okay? But we would find that there are some situations where um, an atom of the same type, okay, it has the same number of proton, same number of electrons, but it will have different number of what? Neutrons. So because of the difference in the number of neutrons, okay, isotope will arise. So that's where now you come up with the definition of the isotope, where we're saying isotopes, these are atoms of the same element, okay, with the same number of protons, with the same number of electrons, but different number of what? Neutrons. So if the number of neutrons is different, then it means the mass number is going to be different. Okay, so let's define some important terms now. Okay, before we dive in deep into the what? The electrons. So when you go on your periodic table there, okay, when you go on your periodic table there, you're going to find most elements are represented in this form. Okay, most elements are represented in this form. So this guy here, the X, represents the symbol of that element. Okay, it represents the symbol of that element. And then this Z here represents the atomic number. Okay, maybe I should be writing. So atomic number here. Okay, atomic number. We said this one is just the symbol of the element. Okay, and then this A here represents what we call as the mass number. Okay, represents what we call as the mass number. So now, what is the mass number? Okay, and what is atomic number? So atomic number, it's very easy. This is just the number of what? Protons. Okay, so the number of protons is referred to as the atomic number. And then the mass number here, this is the sum of the total protons that are present, okay, plus the total neutrons that are what? Present. Okay, so the mass number, you get the number of protons, you add to the number of what? You add to the number of to the neutrons that you have. Then you're going to come up with what we call as the mass number. Okay, so please know that. Okay, so atomic number, the number of protons in the nucleus of an atom, the mass number, the total number of protons plus neutrons in the what? In the nucleus. So the mass number is represented by A, and then the atomic number, okay, is represented by what? By Z. Okay, so moving forward now, we can talk about the isotopes, since we know where they are coming from. Okay, so this is when the element, okay, has the same number of protons, same number of neutrons, but different number of electrons. Then you are going to come up with what we call as the isotopes. Okay, so isotopes, okay, when you get them and then you find their average mass, you will come up with what we call as the average atomic mass. Okay, you come up with what we call as the average atomic mass. So this average atomic mass is just the weighted average, okay? It's a weighted average mass of all isotopes of an element based on their what? Relative abundances, okay? It's the weighted average mass of all isotopes of an element based on their average relative abundances. Okay, so if you missed the definition, don't worry. I'm going to send the notes after the class so that you can actually go through at your own time. All right, so to find this average atomic mass, okay, let's say, for example, I have two isotopes, right? So I have isotope 1, okay, I'll just write isotope 1 here, and then I have isotope B, isotope 2, I mean. So to find the average atomic mass, which is also known as the RAM, okay? So average atomic mass or relative atomic mass is the same thing. So you're going to say the average atomic mass, okay, usually denoted by RAM, or you can say relative atomic mass, is equals to, okay, the mass of isotope 1, you represent it as M1, multiplied by, okay, the percentage abundance of this isotope 1. So I'm going to write percent 1 here, okay, percent 1, okay, and then you say plus the mass of isotope 2 multiplied by the percent for isotope what? 2. So this is the formula that we'll be using in order to find the relative atomic mass or the average what? Atomic mass. So here on the formula, it's very important that you always remember that a percent should always be what? Over 100. So whatever value that you're going to put here for the percent, make sure you divide it by 100, okay? Because a percent is always divided by 100, okay? And then this M1 here, and then this M2 here is simply the mass of the isotope that they are going to give you, okay? So they are going to give you some mass of the isotope, and then you use them in your calculation, okay? So now that I've explained what the atom is, the subatomic particles that are found there, okay? And then based on the neutrons, we find out that they actually cause what we call as isotopes. Okay, we can now solve past exam questions on what? Isotopes. So most of them, okay, they are going to be asking you to find the RAM. And then the other type of question that they ask you under isotopes is to find the percentage abundances. So they can give you this RAM, they give you this mass, they give you this mass, and then they ask you to find this percent and this percent. So there are only two types of questions that will be asked under isotopes, okay? It's either you are calculating the RAM, okay, or you are calculating the what? The abundances. That's all, okay? All right, so let's look at some exam sample questions, okay? So if you have any questions, please feel free to just ask, okay? Feel free to just ask. So we start with this question here. Okay, so the first question, they're saying chlorine consists of 75.5% chlorine 35, okay, and 24.5% chlorine 37. Calculate the average atomic mass of chlorine. Okay, so there we're just going to use um, the formula that we're just from discussing. Okay, so I'm going to say the average atomic mass, which is just RAM, is equals to, okay, the mass of isotope 1 multiplied by the percent of isotope 1 plus the mass of isotope 2 multiplied by the percent of isotope what? 2. So what is the mass of isotope 1? So isotope 1 is this guy here. So here they've said chlorine 35 because there's a 35 on top there. So that 35 is our mass. Okay. So I'm going to say 35 multiplied by, and then the percent for this first isotope is 75.5%. So I'll put here 75.5 over 100 because it's a percent. And then plus the mass 2 is chlorine 37. So that would be 37 multiplied by the percent for 2 is 24.5 divided by what? 100. Okay, so what you are left with now is just to multiply this on your calculator. So I'll use my calculator here. You can also use yours that side to see what you're going to get. So 35 multiplied by 75.5, okay? And then I'm dividing the 75.5 by 100. Okay, and then on the other side, I have 37 multiplied by 24.5 divided by 100. Okay, so trusts you are writing on my board. Okay, let me just cancel annotations. Okay. Okay, let me erase this. All right. Okay, so I was punching this thing on my calculator. Okay, what I find is okay, what I found is 35.49. Okay, so the average atomic mass or the relative atomic mass is measured in units what we call as the atomic mass units. So AMU, atomic mass unit. So this one here will be our what? Our average atomic mass. Okay, so any questions on how we've solved that one? Okay, so if there are no questions, let's look at another example. So this is the second example here. Okay, so here they're saying copper has two isotopes. Okay, it has copper 63 with this mass, okay, and copper 65 with that mass. Okay, and then the percentage abundances, this one has 69.09, this one has 30.91. Calculate the average atomic mass of copper. So I'm just going to say my RAM is going to be equals to, okay, the mass of the first isotope has been given as 62.93 multiplied by the percent, which is 69.09 divided by 100. And then plus the mass of the second isotope, 64.93 multiplied by 30.91 divided by 100. Okay, so this is what we have. So now from there, we just have to multiply whatever we have on the calculator. Okay, so let me do that. So if I multiply 62.93 multiplied by 69.09, okay, I get 4347.23 divided by 100 plus, I multiply this, I get 2007.39 divided by 100, okay? And then I can punch this on my calculator now to get the full answer. Okay, so I get 63.462. So this is what I get. So you round it off to two decimal places. So that would be 63.55 atomic mass units. Okay, so that's the answer there. Okay, let's look at another one. So another one is this one. Okay, this one involves magnesium. Okay, so they're saying magnesium has three naturally occurring isotopes, 78%, okay, of magnesium 24, okay, and then they're saying 10% of magnesium 25, okay. What else are they saying? They're saying 12% magnesium 26. Okay, so if they haven't given you any masses here, you've seen it's different from here. Here I was given these masses, right? Okay, so I can't use those masses there. But if you have not been given these masses here, you've just been given this and that, then you have to use 63 and 65 as your masses. So that's what you can see here. Okay, there's just magnesium 29, magnesium 25, magnesium 26. So I'm going to say my average atomic mass. Okay, so in this case, we have three isotopes. So it's going to be the mass of isotope 1, which is 24, multiplied by 78 over 100, okay, plus uh, magnesium 25 multiplied by 10 over 100, plus magnesium 26 multiplied by 12 over 100. Okay, so this is what we have. So multiply this, okay, and then divide by 100. Okay, so we see that we have 24 multiplied by 78 over 100. So let me write it like this, over 100 plus this one will be 25 multiplied by 10 over 100 plus this one will be 26 multiplied by 12 divided by 100. Okay, so all these are divided by 100. So meaning 100 is the common denominator. So I can just simply add whatever is on top. Okay, so 24 multiplied by 78, that will give me 1872 point, plus 25 multiplied by 10, that will be 250, plus 26 multiplied by 12, that is giving me 312. So this will be equals to, okay, so this will be equals to, let me punch this on my calculator. Okay, so I get 24.34 atomic mass units. So this is when I've rounded it off to 2 decimal places like that. All right, so any questions there, guys? Okay, there are no questions. We now deal with the second type of questions that come under isotopes. So that's where we are finding now the missing percentage abundance.
So I
Someone has a
have a
question?
question.
Yes, you can ask.
I'm a little bit late and I'm behind, so I just need to
Can you
examine
kindly speak up a
the
bit?
message.
I can't get you.
I'm
I can't get you.
saying
Speak
I'm
up a
a
bit.
little bit behind the like
Oh, okay, okay. Where are you
I'm late,
behind?
so I try to just
I couldn't get the last part, but I think I get what you're saying. You're saying you're a little bit behind because you joined the class late, right?
yes,
Hello? Okay, so
yes.
no worries. I'm going to share the recorded video once we are done. So you can watch it. Watch the part that you missed.
So I also have a question.
Yes, you can ask.
Um, what is the SI unit for RAM?
Atomic mass units.
Yes, what is the SI unit?
What do you mean by SI units?
Like, what is the that you are writing end of at the end of the answer?
Okay, okay. Okay, I get it. So this one here, these are the units, okay, in which the RAM is measured, or the average atomic mass. So MU, okay, so the M is average, and then I mean the A is average, the M is mass, and then U is unit. So the units for the RAM are atomic mass units. So they are measured in atomic mass units. The one who was asking, have you gotten it?
Yes, I'm clear now.
All right, all right. Okay, so I was saying we've solved like the first type of questions that come under isotopes. Okay, and then the other types is where now you are finding the missing percentage abundance, or you're finding, which is rare anyway, you're finding the missing mass. Okay, so they'll just give you enough information such that you can find whatever is missing. So we'll start off with a very simple one. Okay, so this one here, you've seen the question they're saying an element, okay, has three isotopes. Okay, an element has three isotopes. So we can say let that element be X. Okay, so there is the isotope 28, isotope 29, isotope 30. Okay, all of them you can see they have different masses. And then here you have the percentage abundances. Okay, so these two here, the X29 and the X30, okay, the X29 has 4.0 4.70%, okay, as its abundance. And then the X30 here has 3.09%. So the question is saying if the average atomic mass is 28.09 atomic mass units, calculate the value of X. Okay, so this one here is very simple because they just want us to calculate this percent here. So we know that the total percent should always be what? 100. Okay, the total percent should always be 100. So if here I have 3.09, here I have 4.7, and then there I have X. If I add all these, I should get the total of 100%. Okay, so I'm just going to say X plus 4.70 plus 3.09. Okay, when I add this, I should get a total of what? 100. Okay, should get a total of 100. So this simply means I'm going to have 4.7 plus 3.09. So this will mean that X plus 7.79, this should be 7 here, and then is equals to 100. Okay, so to find X, I'm just going to take this guy to the other side. So it will be 100 minus 7.79, which will give me what? Okay, so you can consult your calculator. I get 92.21%. Okay, so my X is simply 92.21%. Okay, so that's how we can find the missing value of X there. So this one is very simple, okay? But you're going to see the next one, it's going to be a bit involving. Okay, so let's move to the next one. So this one here now, they're saying an element exists, okay, as two isotopes. An element exists as two isotopes. 65% has a mass of 40 atomic mass units. Okay, and then they're saying the average atomic mass unit is 41.2 atomic mass unit. Find the mass of the second isotope. So remember, the average atomic mass here, okay, is the same as the RAM. So this RAM we said is equals to mass of the first isotope multiplied by its percent abundance, okay, plus mass of the second isotope multiplied by its percent what? Abundance. So now we've been told that the average atomic mass is this, meaning the RAM is this guy here. So I'll write here 41.2 is equals to the mass of the first isotope, we've been told it's 40. So that is 40, okay, multiplied by the percentage for the first isotope, we've been told it's what? 65. So I'm going to write here 65 over 100. Then I'll say plus, okay? The mass of the second isotope is what I want to find. So I don't know it. So I'll just write M2 and then multiplied by what will be the percent of the second isotope, okay? And anyone who can help us, how do we get the percent for the second isotope? You can just unmute your mic and then answer. How do we get the percent for the second isotope? Since we've just been given 1% and this element consists of two isotopes. How do we get the percent for the other one?
Yes, sir. For the other one, since percentage is out of 100, we can subtract 65 from 100 for us to get the other percentage.
Exactly. Okay, so the other percent, we find it by saying 100 minus 65. So that one is going to give you 35 over 100 like this. Okay, so meaning that we can now find this M. So I'm going to say 41.2 is equals to this guy here. It will be 40. Okay, 40 multiplied by 65 and then divided by 100. I get 26 plus here I have 35 divided by 100 and then multiplied by M2. So I get 0.35 M2 like this. So I'll take this guy to the other side. So it will be 41.2 minus 26, which is equals to 0.35 M2. Okay, so meaning that if I want to find my M2, I just divide both sides by 0.35. Even this side, I divide by 0.35. So what do I have? My M2 will simply be equals to, on top there, I have 41.2 minus 26. Okay, and then I divide that answer by 0.35. So I'm going to get my mass as 43.42 857,143. Okay, so I just round it off to 2 decimal places. So this would be 43.43. And the units are atomic mass what? Units. So this one here is the mass for the what? For the second isotope. Okay, so you see that we just have to know this formula here, and then we substitute whatever we've been given to find what we haven't been given. Okay, so let's look at another one. Okay, so the other one is this question here. So this one, they're saying europium, okay, europium has two isotopes with relative abundances, 48% and 52%. The average atomic mass is 151.96 atomic mass units. If the isotope with 52% abundance has a mass of that one, calculate the mass of the other isotope. Okay, so here we're going to say relative atomic mass is equals to mass 1 multiplied by percentage 1 plus mass 2 multiplied by percentage 2. So the RAM has been given this guy here. So I'm just going to put it there. Is equals to mass 1. They said, so which isotope should we take as 1 anyway? Okay, so you can take N. So we're going to take this one as isotope 1, the one with 48%. Then the one with 52, we're going to take it as isotope 2. So here they said if the isotope with the 52% abundance has this mass, calculate the mass of the other isotope. So we said the one with 52 is our isotope 2, right? So meaning we do not know the mass 1, okay? But the percent 1, we know it is what? 48 over 100. Then plus mass 2 is this guy here. So 152.92 multiplied by its percentage, which is 52 over 100. Okay, so more like the previous question. So this will be 151.96 is equals to, here, I'm going to divide 48 by 100 and then multiply by M1. I get 0.48 M1 plus here, I'll say 152.92 multiplied by 52 and then divided by 100. So there I get 79.5184. So make sure you confirm with your own calculator. Okay, and then from here, what are we going to do? We're just going to take like terms to the same side. Okay, take the like terms to the same side. So we're going to say, let's say 0.48 M1 is equals to 151.96 minus 59.5184. Okay, so simply meaning this is equals to, what is 151.96 minus 79.5184? Okay, so I get 72.4416. This is equals to 0.48 and then M1, right? So we're going to divide both sides by the 0.80, the 0.48, I mean. So it means M1 will just be equals to 72.4416 divided by 0.48. So this will just be equals to, okay? So if I divide that number by 0.48, I get 150.92 exactly. Okay, and we know these masses are measured in atomic mass units. Okay, so this will be the mass for the other isotope. All right, so any questions there, guys? Okay, if there are no questions, let's look at the last question. Okay, so after this class, then you should be able to solve any question on relative abundances and isotope. Okay, because I've solved all the types of scenario questions that can come there. Okay, so let's look at the last scenario. So they like bringing this one here in the test or in the quiz or in the exam. They will definitely bring such type of equation that we are about to solve now. So here they're saying an element has two isotopes with masses 10 and what? 12. Okay, if the average atomic mass is 11.3, calculate the percentage abundance of each isotope. Okay, so it has two isotopes. So I'll say isotope 1 here. Okay, and then here I'll say isotope 2. So they've said isotope 1 has a mass of 10. So mass here is 10. Isotope 2 has a mass of 12. And then they've said the average atomic mass, or the RAM, has been given as 11.3. Okay, and then now they want us to find the percent for 1, which we don't know, and the percent for 2, which we also don't know. Okay, so here we need to come up like with two equations, okay, because we have two unknowns. P1, P2 is unknown. So we know that, okay, the percent for this guy and the percent for this guy, if I add them, I have to get 100, okay? Because we said the percent, its total should always be what? 100. So I'm going to say P1 plus P2 is actually equals to what? 100. So simply meaning here, I can make P1 or P2 the subject of a formula. So I'll make P2 is equals to 100 minus what? P1. Okay, and then now I'll write the formula for the RAM, which was RAM is equals to M1 multiplied by P1 plus M2 multiplied by what? P2. So the RAM is 13.3 is equals to, the mass 1, okay, is 10 multiplied by P1. So P1 is a percentage, okay? So make sure you put it under what? Under 100, okay? Or you divide it under 100. So this will be P1, and then all this is just going to be dividing by 100, okay? Or the 100, you can just put it over P1, it's the same. And then here, plus, okay? The mass 2 is 12 multiplied by P2. So now P2, instead of putting P2 here, okay, I'm going to put the expression that expresses P2, okay, in terms of P1. So you can see P2 is the same as 100 minus P1, okay? So here where there's P2, I'll put 100 minus P1 over 100 because it's a percent. So why are we doing this, okay? Because we want to solve this, because this equation, if we had put P2 here, it will have two unknowns or two variables, okay? And if there's two variables, then we can't solve it. So we're trying to express this in terms of P1, and then we can solve the equation that is going to result from there. Okay, so from here, I'm just going to say this is 11.3 is equals to, this will just be 10P1 over 100 plus, and then here it's going to be 12 multiplied by this guy multiplied by the P1. So it will be 12 multiplied by 100, okay? That will just be 1200, then minus 12 multiplied by P1, that will be 12 P1. And then all this, as you can see, it's over what? 100, okay? All right, so you can see that whatever I have on my right here is over 100, okay? So I want to get rid of the 100 in the denominator there. Okay, so what am I going to do? I'm going to multiply throughout by 100. Okay, so I multiply this by 100, I multiply this by 100, I multiply this by 100. Here the hundreds are going to cancel out with this, but here it's going to be multiplied by the 11.3. So what we have now there will be this. Okay, so I'll say 11.3 multiplied by 100. That will just give me 113, okay, and then 0 is equals to, if I multiply this by 100, then the 100 and the 100 will cancel, so I just remain with 10P1, okay, and then plus 1200 minus 12P1, okay, because this guy here is going to cancel with this 100 that we are multiplying with, so like terms together, so it will be 130 is equals to 1200, and then 10P1 minus 12P1. It will give me minus 2P1, right? Okay, this guy goes to the other side. It is 1130 minus 12 hours. If you want to say it in terms of time, then minus 2P1. Okay, so we subtract those two numbers on the left. So 1130 minus 1200. Okay, so that will just give me a minus 70 is equals to minus 2P1. So from there, I'm going to divide both sides by minus 2, minus 2. So simply meaning that the percentage 1 is 35%. Okay, so percent 1 is simply what? 35%. Okay, so after we found the P1, then it will be very easy for us to find the P2 because we're just going to use this formula here. So P2 will be equals to 100 minus P1, which is 35. So I get what? 65. Okay, so simply meaning that the percent, okay, for isotope 1 is going to be, okay, the percent for isotope 1 is going to be 35%. And then the percent for isotope 2 is going to be 65%. Okay, and that's all for this question here. So any questions there, guys? Any questions there? Okay, so if there are no questions, we'll end here for today. In the group, I'm going to post an assignment that you should do, okay? So I was getting all these questions from the past papers, okay? I was getting all these questions from the past papers. I also send an assignment that you should do, okay? So you try to practice, and then you can send those answers to my inbox. All right. So we end here for today, okay? But those who would like to register for our online classes are just 70 kwacha, okay, per course per month. So once you pay that, okay, you will be able to access our website. So our website is discretelearning.com. So you just go on Chrome, you search discretelearning.com, and then you go there. Okay, so this is our website here. Okay, but here I'm already logged in, so it went direct into the account. But if you don't have an account, I'll send the link. So you create your user account on the website, or you put in your name, your email, you create your own password, okay? And then after you are done with that, you can log in. So now, once you log in, you see that we have four courses that we offer for NS, okay, or for pre-med or for NQ, okay? as long as you're in first year. So if it's math, you can see math is there, chemistry is there, physics, biology is there. Okay, so since we are learning chemistry, I'll open chemistry here. I'll show you what is inside. So when you come here, you can see there are two folders. So the one that you do at first year, that's general chemistry. So you open the folder for general chemistry, and then you are going to find 5 folders. So in the 5 folders, we have one which has topic lessons. So whatever chemistry topic that you are going to learn, okay, we've already solved, we've already taught, the videos are there for you guys to learn at your own time, at your own pace, even in your blankets, okay, even when you are sleeping, you can still be learning. So when you open this topic lessons folder, okay, you are going to see that all the topics are there, okay. I don't know why it's delaying to load. Okay, let's wait for it. Okay, so when you open this topic lessons folder, you'll find like all the topics that you can have in chemistry. So you can see them here. So from introduction to chemistry, units and measurements, what we've been doing the past weeks, accurate, precision, uncertainty, errors, they're already there, the lessons, okay? Atoms, molecules, isotopes, like the ones we did today, the videos are already there. The more on stoichiometry, you're going to find it there. Solutions, stoichiometry, all the topics that you're going to actually do at first year, they're there, okay? So you can use this to learn at your own time, at your own pace, okay? So apart from accessing the topic lessons, you can also access summarized notes. So there are summarized notes here, very direct to the point of whatever you want to know. So you can come in that folder, you find the summarized notes if you
Guys, our star has gone.